In this question, we have a 50-kilogram box, which is just left sitting on a ramp that has a 30-degree incline. And we want to know what is the coefficient of static friction. Now the first thing you want to do is draw a free body diagram. And now remember, because our object is on an inclined plane, we need to use a tilted axis. So I will draw my x and y axis at an angle. And then I can draw my free body diagram. So I draw a point to represent the box, I draw the force of gravity straight down, and then I draw the angle of the incline between the force of gravity vector and the y-axis. And now because the force of gravity vector is at an angle, I can break it up into an x and y component. So we have FGY and FGX. And because the box is on a surface, we also have the normal force, and the normal force is always perpendicular to the surface. And now the final force is static friction. Based on the forces we've already drawn, the box will slide down the incline. But we know the box is not moving. So what force would be resisting the motion of this box? Static friction. And so we have to draw the static friction vector going up the incline. So it's resisting the motion of this box. Now that we have our free body diagram, let's move on to writing our F-net equations. We will write an F-net x equation, which is the sum of all the forces acting along the x-axis. So we have the static friction minus the x component of the force of gravity. The static friction is positive because it's pointed to the right, whereas the x component of the force of gravity is negative because it's pointed to the left. We can replace F net x with 0 because the box is not moving. And we can also replace the x component of the force of gravity with mg sine theta. And now if you're wondering where I got that value, we can use vector addition. So we have FGY, and we can add that tip to tail to FGX, and the resultant is the force of gravity. Now we have a right angle triangle, which means we can use trigonometry to solve for each of the sides. So I will use sine theta, which is equal to opposite over hypotenuse. The opposite side is FGX, and the hypotenuse is FG. We can rearrange and isolate for FGX and replace the force of gravity with mg. And that gives us FGX is equal to mg sine theta. And now we can rearrange and isolate for the static friction, and then we can replace the force of static friction with mu s n. And from there, we can isolate for the coefficient of static friction, mu s. And looking at this equation, we have the mass of the box, we know the acceleration due to gravity, and we have the angle of the incline. So what we're missing is the normal force. How do we find the normal force? Well, we do an F net y equation, which would be the sum of all the forces acting along the y-axis. So we have the normal force minus the y component of the force of gravity. We can replace F net y with 0 because the box is not moving up or down along the y-axis. And we can replace the y component of the force of gravity with mg cos theta. And if you're wondering where I got that value, well, let's return to our right angle triangle. Now we can use cos theta, which is equal to adjacent over hypotenuse. The adjacent side is FGY, and the hypotenuse is FG. We can then rearrange for FGY and replace the force of gravity with mg, and that gives us FGY is equal to mg cos theta. And then from there, we can just rearrange and isolate for the normal force, plug in our values for the mass of the box, the acceleration due to gravity, and the angle of the incline, and we can see that the normal force is equal to 424 newtons. And now we have everything we need to plug into our equation for the coefficient of static friction. And what we find is that the coefficient of static friction is equal to 0.58. And that's the answer to this question. This showed you how to answer forces questions when the object is on an inclined plane.